Hi class, welcome to your very first lesson in chemistry. I am so excited to be teaching you this year. When you follow through this lesson, make sure that you have the guided notes provided for you on Google Classroom, a Regents chemistry reference table, and a calculator available. Making sure you're prepared will help ensure your success in this course. In today's lesson, we are going to discuss metric conversion. By the end of the lesson, you should be able to identify metric base units of measurement and convert between units of metric measurement. Let's get started. Before we get too deep into metric measurement, since this is our first lesson of an exciting year of chemistry, let's make sure we understand exactly what we're going to be studying this year. Chemistry is the study of matter and the changes it undergoes. So the first question is, what is matter? Well, matter is anything that has mass and takes up space. So one thing that you should already know about matter is that all matter is made up of atoms because atoms take up space and have mass. Now, different types of atoms can have different properties. So here you can see copper and aluminum. We can see that both of these substances are made up of atoms, or these little spheres, but the atoms of copper are closer together, thus giving copper a greater density than aluminum. Now, chemistry is not only the study of matter, but it's the study of the changes that matter can undergo. Matter can undergo either physical changes or chemical changes. In a physical change, matter, which is made up of atoms, is rearranged, but no new bonds are formed or broken. So that means that the name and the formula and the properties of the substance will be unchanged after a physical change. So here you can see that we have 3 flasks of water that are undergoing a physical change. We are changing from solid to liquid and then to gas. But when we look at the particles, each of these particles contain water molecules, or one red oxygen atom bonded to 2 white hydrogen atoms. So this always has the formula of H2O. Now, during chemical changes in matter, new bonds are created or broken. When we make or break bonds, we create new substances with new names, new formulas, and new properties. So here we have a picture of cooking gas, and if you don't light cooking gas when it's not burning, it has a different smell than cooking gas after it burned because its properties change during this chemical reaction. And you can see from the formulas below that CH4, also known as methane, and oxygen combine to make new compounds of carbon dioxide and water. So the name and the formulas have changed here, and the properties change as well. When we burn the gas on our stove, we're burning a substance called methane. Now, methane must combine with oxygen to burn and produce carbon dioxide and water. So during a chemical change, the names of the substance change, and that happens because as we look at the molecules, we can see that the formulas change. So we can see that methane and oxygen have different bond structures than carbon dioxide and water. And we know that the properties are going to change. So when we burn methane, we're burning a substance, but in the end, we're creating water, a substance that actually puts out fire. Now, in chemistry, like all science, it is very important that we make measurements. We make our measurements in our experiment, we report our results, and we go and make sure that our results match scientific standard and we execute the scientific method. all measurements in chemistry must include both a number and a unit. So here we have a couple measurements that you could observe, like 35 meters or 0.25 liters. But you always have to have a number and a unit in a measurement. Now, in the metric system, we begin with things called base units that are found on your Regents chemistry reference table. Now, here you can see some base units, and you might be familiar with some of them, but some of these base units will be new. Again, if you're unsure what a unit is measuring, just look it up here on your reference table. So a meter is abbreviated with a lowercase m. A gram is abbreviated with a lowercase g. And a liter is abbreviated with the uppercase L. But you can see that we have other units like the MOL, which is for the mole, and that represents a quantity or amount in chemistry. So, I know that you can do this. Let's look at the guided notes provided. You might have to print them out yourself, but you can access them easily in Google Classroom and try and fill out this information using reference table D. Make sure you pause the video. By now, you should be able to identify the base units of measurement. Again, you can use your reference table to help you. Do not need to memorize this. Now, in the metric system, in addition to the base unit, we can add a prefix before the base unit to indicate the magnitude of a measurement. Now, these prefixes are found on reference table C. And the factor listed that describes the prefix tells us how many base units are in a measurement. So 1 kilogram is 10 to the third or 1,000 grams, while 1 milliliter is 10 to the negative third or 1/1000th of a liter. Now, milli is always 1/1000th. So when we have a milligram, we still have 10 to the negative 3 or 1/1000th of a gram. That means that most of the medication we take these days is measured in milligrams. So it is important that the person measuring your medicine, or yourself if you're measuring your medicine, understands the metric system. If you take a gram when you are supposed to take a milligram, you take 1,000 times greater dose than is prescribed. Now, there are lots of ways to convert between the different metric measurements, but I like to use what I call the power of 10 number line. So take a minute to write down these 3 steps on how to use the power of 10 number line, and then I'll show you exactly what to do. Now, one of the most important parts of the power of 10 number line is that you don't forget any of the powers of 10. So when we look at our reference table C, we can see that not every power of 10 is written here. So we do not have the 10 to the power of 2, but in order to use a power of 10 number line, you need to have that tick or measurement there. So we won't have to name it, but we need to include its place on the power of 10 number line. And I like to use this mnemonic device where king for kilo, Henry, which is hecto, but we don't need to know that. We just need to keep the place for 10 to the power of 2. King Henry doesn't usually drink chocolate milk with 1, 2, 3 monks, 1, 2, 3 nuns, and 1, 2, 3 priests. Let me show you what this means. So now I'm going to show you how to use your reference table to make a power of 10 number line that will allow you to complete some metric conversions. So starting with your reference table, the first thing you want to do is turn it on its side so that the seam is at the bottom of your page, like this. And so this will help us orient the power of 10 number line. We are going to want the power of 10, 10 to the third power on the left, and the power of 10, 10 to the negative 12th power on the right. We're just going to make a number line. So to do that, what we're going to do is we're going to start with 10 to the third. We're just going to list the powers of 10 in order. So 10 to the second, 10 to the first. Now this is really important. You must also include 10 to the 0. So we're counting by ones as we make our power of 10 number line. Now, how we know which powers of 10 that we are going to use in chemistry is from this. So we know that we use the kilo, 10 to the third, and then we also use the deci, which is 10 to the minus 1, and the centi, which is 10 to the minus 2, and the milli. Now, notice that after milli, there are some breaks here. So I like this mnemonic device that reminds me where all of these go. Now, some of the powers of 10 we don't typically use in chemistry, so they're not listed on table C, but it's very important that they're found in your power of 10 number line. And I remember how to orient my power of 10 number line using the saying King Henry, so this power 10 to the second is actually called a hecto, but we won't use it in chemistry, doesn't usually drink chocolate milk, and then with 3 monks. So this is 10 to the negative third, 10 to the negative fourth, 10 to the negative fifth, 10 to the negative sixth. So I didn't have to write the numbers, but I do need to leave the spaces for those powers of 10. So this the word here is with 3 monks. We see that's because it's a micro, but it has this Greek symbol. And then it's 1, 2, 3 nuns. So this is 10 to the minus 9 is nano, and 1, 2, 3 priests, which is 10 to the minus 12. So there's at least a tick for all of the powers of 10. And one of the most important powers of 10 is here, 10 to the 0. This is U. This is the unit. And the unit usually only has one letter in its measurement. Like a meter, which is a M, or a liter, which is an L. So to use the power of 10 number line, let's look at this example where we want to convert from milliliters to liters. So we're going to start with the number, and then we're going to find the prefix for milli. Milli is 10 to the negative third, and we want to go to liter. That's only one letter, so that's the unit. So we need to go, and if I start at milli and go to liters, I see I need to move my decimal to the left, and I need to move it over 1, 2, 3 places, because there's 3 difference between 10 to the 0 and 10 to the negative third. So the decimal was here, and I'm going to move it over 3. So when I write my answer, it's always a good idea to include the leading 0. So this is the conversion. Let's do some more. So here we have milli, and we want to convert to nano. So what I can see is that milli is 10 to the negative third, and nano is 10 to the negative 9. So to move from milli to nano on my number line, I need to move to the right. And I will need to move 6 spaces. So I need to move my decimal 6 spaces to the right. I'm going to write down the original number first. And then I'll start moving my decimal. So here's my decimal. I'm going to move it over 1, 2, 3, 4, 5. And now I'm out of decimal places. So I'm going to just add a 0 and drop the new decimal place. So this number will be written as 8,970. Okay, let's look at this conversion. Here, we would like to move from milli to pico. So you can see that milli is 10 to the negative third, and pico is 10 to the negative 12. To move from milli to pico, we're moving to the right, and we'll have to move our decimal 9
places. So our decimal is here, and since we don't have any more places to move, we're just going to have to add 9 more zeros. One, two, three, four, 5, 6, 7, 8, 9. So this is a really large number. Typically, we would write such a large number in scientific notation. So this could be 4.57 times 10 to the 13th power if we write it in scientific notation. More on that later. In this final conversion, we want to convert from kilojoules to joules. Joules only have one letter, so that's a unit, and kilo is at 10 to the third, so we want to go from 10 to the third to the unit. We can see that this is 3 spaces to the right, so we're going to have to move our decimal place 3 spaces to the right. So the decimal point was here. I'm going to move her 1, and since I don't have any more spaces, I'm going to have to add zeros. 2, 3, drop it down. So 502,300 joules would be our answer here.
There's another way to complete metric conversions, and that is to come up with the fraction that lists the factor compared to the base unit and carry out multiplication that will cause units to cancel. This is called the factor label method. We will not use the factor label method in class, but if you are comfortable with this method, you're more than welcome to use it. I will always use the power of 10 number line. So here in this problem, we want to convert between kilojoules and joules. We know that joules is a base unit because joules only has one capital letter. So most of the base units only have one letter. And then here we have the kilojoule. Now on reference table C, we can see kilo are 10 to the third joules. So there are 10 to the third joules, base units, in 1 kilojoule. So I want to write a fraction so that kilojoules are on the bottom. So when I multiply, they'll cancel out. And joules are on the top. And I'm going to make sure that I put the factor with the base unit. So there are 10 to the third joules in 1 kilojoule. And then I'm just going to multiply to get my answer. Now, this is the same answer that we got when we used the power of 10 number line. So again, this is just another technique. Here's one more example. If you're comfortable with the factor label method, why don't you try it with this question? So this should be your setup. Make sure that the factor always goes with the base unit. And notice how our answer matches the same answer we got when we used the power of 10 number line. So by now, you should be able to convert between metric units of measurement and make sure you've taken good notes. You complete your homework on Google Classroom, and you bring any questions you have to class. I'll see you soon.